right? Sure? Okay. The denominator can be written as summation, okay, xtzt upon summation zt square into zt into yeah. Now what? Now what? We can take summation xt zt, summation zt square.
Yeah, and cut it with 1, 1, and we'll have zt square in the other bracket.
Okay, so what will you have at the bottom?
You will get another summation xt zt upon summation zt square
Okay.
into zt square.
Into zt square, right? So our problem will be solved that way. Yeah, obviously, because so your suggestion is to take summation xt zt, summation zt square out, right, from the summation, right? So if you do that, you will get the following. Okay, if you do that, you will get the following. Can I wipe this off? Okay. Okay, I think I can write it here. Okay, so if I do this, I'll get summation upon see, this is summation zt, right? So basically this is this. Yeah? Sure? You see this? See, what is this? This is summation AB, okay, right? So if your summation, so if you have, okay, so you can take summation xtzt into zt, right, and summation xtzt, so you will really have summation xtzt square, I'm sorry, xtzt square into summation zt square.
But then you can cut them.
You can cut one of them, right? So what will you get? So from cutting them, what you would get is, you would get this, right? So we can cut this and this, right? So what will you get? Which is what? ZY covariance XZ, which is also a instrumental variable estimator. So what we have shown is a two-stage least square estimator is nothing but an IV estimator, an instrumental variables estimator. Okay, two-stage least square is nothing but an instrumental variables estimator, and because instrumental variable estimators are consistent, a 2SLS estimator will also be consistent. A 2SLS estimator will also be consistent. Sure? Is this clear? Everybody gets this? Let us try to see if the 2SLS estimator is necessarily unbiased. Let's see if the 2SLS estimator is necessarily unbiased. Okay? So let's try to find out. Okay? So we have So we have, okay, so I have beta 2 SLS, okay, beta hat 2 SLS is given to me as summation zt yt upon summation xt zt is the 2 SLS estimator, right? Now let yt be equal to beta xt plus et, and we want to estimate beta. What we have is beta hat TSLS. We want to see how beta hat TSLS is connected to beta. We want to see how beta hat TSLS is connected to beta, right? So this would then be summation zt sure. This will then be plus now this will cancel out. Summation xtzt is nothing but summation xtzt. So we have the important identity beta hat TSLS. Beta hat TSLS is equal to beta plus, if I divide both sides by 1 upon n, I have actually 1 upon n summation zt et by 1 upon n. Now please friends remember, so beta TSLS is this. As n becomes large, we have the law of large numbers kicking in. So as n becomes large, what we'll write is the probability limit of beta hat TSLS as n tends to infinity will be equal to beta plus, what will summation ZTET upon n go to? Expectation ZTET. Right? Expectation ZTET. So this will be expectation ZTET. Upon what will this be? Expectation XTZT. Right? Everybody knows that these are averages, these are sample averages which will go to the expected values as n becomes large. Right? Now, what is expectation XTZT? Expectation XTZT is the correlation between x and z, which is not 0. X and z are correlated. But what is the numerator? The numerator is the correlation between z and e. And the correlation between z and e is 0 by definition. Right? So this part will be 0. This part will tend to 0. And therefore, we'll be able to show that probability limit of beta hat TSLS as n tends to infinity is beta. Which means that the TSLS estimators, just like the instrumental variable estimators, are consistent estimators of beta. Whereas OLS estimators are not. Why are OLS estimators not? Because the correlation between x and e does not go away as n becomes large. Right? This does not vanish. But because now we have reconstructed things in such a way that the last part vanishes, therefore these estimators are consistent. Sure? So what is the entire upshot of the story? That if you have endogenous variables, you cannot use OLS. Because OLS estimators will be neither unbiased nor consistent. So what do? You replace them by an instrumental variable. How do you find an instrumental variable? If you are in a system of equations, then the order condition helps. Look for other equations in which there are some exogenous variables which include other equations but excluded from this equation, and make sure the order condition is satisfied. Right? Secondly, you can also think of a, so that's how we construct instrumental variables. We thought of two-stage least square estimators, TSLS estimators, as another way of thinking about instrumental variables, and what we have shown is that both will be identical and consistent, unlike an OLS. Is this clear, friends? Is there something that you need me to clarify? Why are the OLS estimators not consistent? We know that they are biased, right? But we know why are the OLS estimators not consistent. And the OLS estimators are not consistent because we know beta hat OLS is beta plus yeah, we know this equation. So we have yeah, right? So if you think of the probability limits from which you have because beta is a constant, the first part probability limit will be a constant, we have yeah? It should be x dash e, summation xi ei, right, the average value, right, and summation xi square, that is x dash x really, okay. Now the denominator will be the variance of x, as n becomes large, summation xi square, because remind you, expectation x square we assume to be 0, because this is a model without an intercept, right, so this will give you the variance of x. This will be the covariance between x and e. So unless we assume that the covariance between x and e is 0, this is not going to be, this term is not going to be 0. But the whole problem was because if there is endogeneity, we showed that there was no, the correlation between x and e could not be 0. Because the expected variable error term were correlated always. So this will not be 0 in general in a OLS model if x is an endogenous variable. Whereas in a instrumental variable estimator, that condition can be shown to be satisfied. So instrumental variables will be consistent by construction of instrumental variables, whereas OLS will not be consistent. Is this clear? Yes. Thanks for asking this question. It was a very important question because when I dealt with the OLS, I had not dealt with this issue because I never imagined I'd be talking about the large sample properties in a basic econometrics class, but good that we talked about that. Yeah, any other doubts? Any doubts over all the lectures that we've done so far?
So we had 7 EB discussion.
No, we'll not do that today because that is module 3 and 4. Module 2 and 4. Whereas for this exam we'll have module 1 and 3, and we have, I think what we've done is a very compact test kind of thing. I don't want you to overflow with ideas we'll meet and deal with that, right? On the 24th, friends, we are having a full day workshop on that time maybe we'll discuss a lot of heteroscedasticity and other things. Simply on the multiple linear regression model, it will be a hands-on workshop in this classroom where we'll be using an open source software called R to actually conduct regressions. It will be kind of a lab session on the 24th, which is a public holiday, and therefore this classroom will be available to us the whole day without any distraction. So when is your exam though? Well, then we can postpone that. Yeah? Well, that is essentially meant for you folks. Right? Okay. Or I will conduct a small workshop for all those who are interested, but I will repeat that workshop again. Were you there for the last workshop, any of you? So did you find that useful, that R and everything? Right, so I think that's something which you must learn, all of you. And fortunately now in this room we have the facilities. We have an LCD and we have places where we can charge our laptops, and we also have sufficiently many laptops in our laboratory, so we can also give you the laptops, right? Okay, so after you finish your exams, but they'll have to be on a public holiday, so you'll have to come on a public holiday. Right? Sure. Any other doubts you folks might have on the syllabus, what you've done so far? Any gray areas? Are these videos helping you? Yes. You can watch them? Yes. Okay. How are the remedials going in econometrics? They are useful? The Bhavesh sir is useful. The micro macro? They're not very useful? You mean you think we should tweak those remedials? What are your suggestions to make those remedials more useful to you in micro macro?
Sometimes these remedials are confusing because whatever taught in the class, and sometimes they are going to teach something else.
They teach something else. So there is no coordination between. Yeah? There is no coordination between, and I think also in econometrics that might be happening. In the remedial you have covered most of the things. And the math eco? Do you need a remedial math eco? Not really.
So, if it's possible for after our midterm, if we could have the remedials for a couple of subjects starting along with the lecture, it would be great.
Sure, so they should run along.
Yeah, because last time we sort of put in more effort. It would have been easier if it
Right. No, what do you mean with along in the sense that when the lectures are held, you want the same in the same week the same remedial? Okay. Sure. So we can do that. That's a good idea. Especially for micro. Are your lectures still happening with PowerPoints? Ah, okay. You think PowerPoints are a problem, no? It's yes. I'll write for you a reference book, but instead